Modern, high-level computing abounds with literally thousands of different programming languages for a beginning programmer to choose from and learn. These programming languages range from the ultra-simple, such as the chicken programming language, where the sole command available is the word chicken. The number of chickens on a line denotes what command to execute. Then, going one level of abstraction higher, there are middle-of-the-road, general-purpose languages which are only mildly difficult. You're probably familiar with these. They include Java, C++, C, and other such languages which may require about a week to get familiar with. Then there are truly esoteric languages such as Perl, which look the same before and after encryption. With all this choice between the various programming languages that I mentioned before, Java, C, Perl, even Chicken, why should you choose Python above all other languages? Python is close to English and easily understandable for humans. You saw the example Perl code and how undeniably difficult it was to read. Python's not like that. Python is easy to read, similar to English, and easy to understand at a glance. In addition, because Python allows you to enter and receive feedback from commands in real time, it's very easy to develop. If you have a new idea you'd like to try out in C++, you have to write an entire program. Then you have to compile it, then you have to run it. In Python, it's not like that. You can just open up the Python shell, type a command, and get some feedback back. Test out ideas. Like a notepad, except that it talks back to you. Python is designed to make simple tasks easy to program in a clear manner, much in the same way you would instruct a person to do something. Lastly, Python is object-oriented. You can represent the various different properties and methods of an object. We'll come back to that later. Here you can see, in green, a simple Python program and its clear syntax. It asks the user a yes or no question and replies differently for yes and for no. We've done some theory about how Python works and why Python is a good language to learn. Let's learn it. The most basic building block of a program is a variable. Variables are boxes that hold values. In the terms of the human brain, they're memory. A variable can remember a number, 1, 2, 3, 4, 5.76, 5e to the negative 7th, all hexadecimal numbers, binary numbers, you name it, numbers. They can also hold strings, which we put in double quotes and contain text. Let's just define a simple variable in the Python shell. This is the REPL, or notepad that talks back, that I referred to earlier. To define a variable, we say variable name. Let's call it my first variable. Then we put 1 equal sign, and then what we want it to be. Let's make this a number. 57. Now, we want to look at the value of my first variable. Let's type my first variable. Tells us it's called 57. What if we wanted my first variable to be 1 higher? We would say my first variable equals my first variable plus 1. Now, let's take a look at it again. My first variable. 58. 57 plus 1 equals 58. Simple math. Now, there are also string variables. Let's make one. We'll call it my first string. And remember, one equal sign, just one equal sign to define a variable. Equals. And strings, remember, we put in double quotes. Within the double quotes, we will write, hello world. It's a classic programming phrase. Press enter, and my first string is hello world. Let's check, let's type. My first string, enter, says hello world. And those are variables. Now this is the REPL. You type something, gives you stuff back. In non-REPL Python, where you store your program in a file, to output to the screen, we use print. Works like this. We say print with parentheses. Inside the parentheses, we put what we want to print. So let's print out my first variable. Type it in. Print my first variable. Press enter to run it. 58. If you remember, that's what we set it to. Let's try print my first string. Hello world. It works. Now, let's move on to conditionals. Now, to explain conditionals is a little difficult, although not as difficult as explaining object-orientedness. Basically, it's how the computer makes a decision. You do this all the time. Let's think about programming a coffee maker with a bunch of different flavors inside it. How does it pick? Well, it picks according to the favorite flavor of the person operating the coffee machine. So, it would be the coffee maker would be programmed something like this. If mocha is in this coffee machine, make mocha coffee. Else, if there is no mocha, but there is latte, make latte. Else, if there is neither mocha nor latte, put in hot water and try to fool the user into thinking it's coffee. I'm sure somebody would believe that. You can also have multiple else-ifs. So it could say, if flavor A is present, do something. Else if flavor B is present, do something else. Else if flavor C is present, do yet another thing. Else neither A, B, nor C is present, do one final thing. Give the user plain water and try to fool them. Let's make one. The precise syntax for an if goes like this. If, and then whatever you want to test. In the coffee example, it would be the presence of mocha. Let's just test whether the variable we made earlier, my first variable, is equal to 58. It is, but the computer doesn't really know that right now. Or if it does, it doesn't know it knows. So let's say, if my first variable. Make sure you spell it right. The computer has no spell check in Python. Now, when you're comparing two values, you use two equal signs. I want to make this very clear. You will get an error if you do not use two equal signs. You must use two. When you set a variable to something, you use one equal sign. When you're comparing a variable in an if or an elif or an else, actually not in an else, you use two equal signs. If my first variable equals 58, colon. You have to put a colon after the if statement. Press enter, and now it moves your cursor over. What we're going to type now is what happens if my first variable is 58. Let's just print a string which says my first variable is equal to 58, not a type of coffee. Press enter. Press enter again because now we're on an empty line. And it says my first variable is equal to 58, not a type of coffee, because my first variable is equal to 58. Now let's test something that's false, something that's not true. Let's do if my first variable is equal to 42.5, colon, enter. Now what should we print if it's true, which we know it isn't? My first variable is equal to 42.5, which is also not coffee. Press enter again, nothing happens. Why? Because we know that my first variable is 58 and not 42.5. What if we wanted to do one thing, if something is true, and then if something else is true, do another thing? That's where elif comes in, short for else if. Let's do if my first variable equals 79.123, print it is 79.123. It isn't. Now, we pressed enter, now we're going to press backspace just one time. We're going to say elif, which it means else if, my first variable equals 58. Press enter. Print it is 58. Oh, and remember, quotes on either side of the string. Press enter again. It's 58. What happened here? The computer saw, if it's 79.123, do this. The computer thought, it isn't. Silly programmer. It went to the next line. Else if it's 58, computer thought, it is. And so it printed, it's 58. That's variables that's conditionals, but there's one last conditional. Else. If all the other things we're testing fail, then it defaults to the else. So let's do this. If, just to shake it up, we'll use the string this time. My first string equals, remember, 2 equals, bongos, type of drum used in Africa. Then print it was a bongo drum. It isn't now. Press backspace once and we're gonna say elif, my first string, double equals, timpani, another type of drum, not from Africa though, colon, enter, print, it was a timpani drum. Neither of those things are true. With our superior human intelligence above the computer, we know that. But we need to give the computer one last thing to do if it notices that neither of these things are true. That's where else comes in. We say else, we say nothing after it except the colon. And we say print, well, it wasn't It was not a bongo or a timpani. Enter. Enter again. Says, well, it was not a bongo or a timpani. That concludes conditionals. Now we've done variables, we've done conditionals. With these, you could theoretically write any program, right? If you wanted to do something twice, you'd write it twice. If you wanted to do something 3 times, you'd write it 3 times. Let's try it out. Print hi. But I don't want to see hi once. I want to see 3 highs because I'm really enthusiastic at greeting. So I'll do it again. I'll say hi again. Another hi. Hi again. We have 3 highs. What if we wanted 3 million highs? Sure, type in 3 million and have fun doing it. Pause the video, do that, come back if you're still alive by the time you're done. If you don't want to do that, we'll move on to loops. Loops are a way to repeat something a given number of times. The while loop works by saying how to do something when the condition is satisfied. So we could say, while my first string is equal to hello world, print out hello world again. Let's try it. While my first string equals hello world, colon, enter, print, the loop is still going. Press enter again. And you know what? Since my first string is hello world and always will be, it's just gonna keep going forever. It'll get to 3 million eventually, if the computer doesn't explode first. To stop it now, before your computer explodes, which it probably won't, hold down the control key. Yes, the control key, not the command key on a Mac, and then press C. It'll give you a, you stopped me, why'd you do that error, but just ignore that. Now, that's a while loop. It does something while the condition is true. What if you didn't want it to go forever, 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 forever? Well, then you would make a variable that will change. So let's say I want to print hi 10 times. I'll make a variable called number underscore of underscore his, highs. We'll set it equal to 0 so far. Enter. Now, while number of highs, and it should be mentioned here, you can't use spaces in variable names. Stick to letters and underscores, and don't start them with numbers. Now, while number of highs is less than, use the less than sign, 11, which will give us 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are all less than 11, colon, print hi. But wait, there's more. Number of highs is 0. This loop will always return true and keep going because 0 will always be less than 11. But we want number of highs to get bigger every time we say hi. So we're going to make hi each time the loop goes, number of highs each time the loop goes, 1 bigger. We know how to do that. We saw it in the variables section. Number of highs equals, 1 equals sign, number of highs plus 1. Press enter again. And we get, voila, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As it turns out, and you should notice this, if you say that it's less than 11, it will go to 11, not to 10. So we should have said less than 10 in the while loop up here. Now, that's while loops. What if you wanted an easier way of doing this? This looks kind of ugly. You have to say number of highs is number of highs plus 1. Why not just make it so that number of highs automatically goes up by 1 each time? That's what for loops are. Let's make one. First of all, set number of highs back to 0. Now, for a for loop, we start it with 4. I know you thought it would start with bongo, apple, flying elephant, but it actually starts with 4. So, we say for number of highs, space, in range 0, 11, colon. What does that do? Well, we're given range 0 to 11, and range 0 to 11 will give you the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, number of highs will start out as 0 the first time this goes, then it'll go to 1, then it'll go to 2, and it'll keep going until it reaches 10. Press enter. We're going to print high. Now press enter again, but don't press enter again, because just to see, we're going to also print number of highs. Enter, enter. This is what you get. So it does the high on the first time, and we see number of highs is 0. Next time, high again, but this time number of highs is 1. So we know that's how a for loop works. Now there is one last construct. This one just shook the world of programming when it was invented. It's called object-orientism. We'll make a separate video for that. It's too complicated for now, and you don't really need it. Plenty of good programs have been made without it, although it can make things easier. Bye. Now, theoretically, with what I've given you so far, you could write any program. You have loops for repeating, you have variables for memory, you have conditionals for decisions. However, you'll often find when you're programming that maybe you're going to want to execute one block of code many times. You say, well, why not loop? Well, the block of code may not always be used 1, 2, 3 times. It may be used once, then we do something else, and then we do something else, and then we do it again twice, the original block twice, and then we do something else for a while, and then we go back to our block. How do we do this? We will define a new command called a function, which does what's in the block. Syntax for defining a function. DEF space stands for define. Function name, we'll call it my first function. Open parentheses, close parentheses, colon, enter. Now, what should we type in here? Well, let's make this function say hello world, because we know how to do that. Remember, print, open brackets, open double quotes, hello world, close quotes, enter, enter. Ta-da! Now we can say, my first function, open brackets, close brackets, press enter, and it does it. We can even say it again, my first function. Now, here's the thing. Functions can return a value. Let's think about this. Variables, we know variables, they hold a value. Now, you could just assign a value to a variable. Say, my variable equals 5. But it may not always be 5. You've got to change it somehow. You can't just add or subtract 1. You may need to do more things with it. You could set the variable to what the function gives back. So let's define a function that gives something back. Define function which returns. Return is the word which means gives back. Brackets, colon. What should the function return? Let's say this function returns 7 times 9. Enter. Enter again. Now let's call the function which returns. It'll give us 63 because that is the return value of the function. Now we can store this return value in a variable. We'll say my variable equals function which returns brackets my variable, and I spelled it wrong. Name error means it doesn't know what you're talking about. Remember, name errors, don't be afraid of them. It means you've probably mistyped something. Say my variable 63. Now, if you've got a function which is essentially a machine that gives something back, it should also get input. It's like a number machine. It takes in a number or text and gives out number or text. The number that's input is called the argument, and it goes between the brackets in the definition. Let's make a function which multiplies two numbers and returns the product. Def multiply. Inside the brackets, the names of the arguments. Let's call them factor A and factor B. Close brackets, colon, enter. Now, what do we need to return? We need to return the product of factors A and B. Product, by the way, is the asterisk. So return factor A star factor B, enter, enter. Let's try it out. Multiply 5, 6. Works like that. Enter. You get 30. You could even put it into a variable. My variable equals multiply 5, 6. Enter. My variable. It's 30. What do you know? Those are all the basic Python constructs. In the very next section of this lesson, we'll use all these constructs to make a simple program.